What if I told you that time travel isn't just science fiction anymore? That somewhere in the equations of modern physics, there's room for moving not just forward, but backward in time. Constantly flowing from past to present to future. But in physics, especially in Einstein's theory of relativity, time is not so simple. For astronauts on the International Space Station, time actually moves slightly slower than on Earth. That means, technically, they a tiny bit younger than they would been if they stayed on the ground. So yes, moving forward in time is possible through speed. And the faster you go, especially approaching the speed of light, the more pronounced this effect becomes. Imagine the fabric of space as a sheet of paper. But here's the problem. Wormholes are entirely theoretical. No one has ever observed one. And even if they do exist, they might be extremely unstable. Any attempt to send information or objects through them might cause them to collapse instantly. At the microscopic level, particles behave in bizarre, unpredictable ways. Some interpretations of quantum mechanics suggest that particles can influence each other across time. This is called quantum entanglement. Time might not be a rivulet, might be a landscape. Traveling to the future is not only possible, it's inevitable depending on how fast and how far you move. Traveling to the past remains a mystery of possibility predicted by math, yet never observed. Maybe it's hidden behind the veil of quantum reality. Maybe it requires technology we haven't even imagined. Or maybe, just maybe, someone in the far future has already done it, and is among us, watching silently. Everything that ever happened, and everything that will happen, might already exist somewhere in this vast terrain of space-time. We're just experiencing it one moment at a time, like a needle playing along the grooves of a record. While it doesn't mean we can send people back in time, it hints that time may not be as linear and straightforward as we experience it. To stabilize them, we would need something called negative energy or exotic matter materials that may not even exist. Though the energy requirements and technological demands are far beyond our capabilities today, proposing the chronology protection conjecture. Meanwhile, the late Stephen Hawking argued against the possibility of backward time travel. He believed that the laws of physics conspire to prevent time loops and paradoxes from ever occurring. Or if they do, only in quantum fields at microscopic scales. Now, fold that paper so that two distant points touch. The most famous is the grandfather paradox. Remember, the future may already be watching. And if this journey through time blew your mind, in other words, the universe is self-consistent. Don't forget to like, subscribe, and share it with fellow explorers of the unknown. It suggests that even if time travel to the past is possible, events would always adjust in such a way that paradoxes cannot occur. If you go back in time, you can't change anything in a way that creates a contradiction. That means your parent and ultimately you would never be born. You can participate, but not alter the outcome. Imagine going back in time and preventing your grandfather from meeting your grandmother. But if you were never born, how could you go back and prevent their meeting in the first place? A wormhole is like punching a hole through both points and connecting them with a tunnel. If one mouth of the wormhole experiences time differently than the other, say. According to this, if you go back and change something, you don't rewrite your original timeline, you create a new one, parallel to the first. Both timelines exist, but you now live in a different branch of reality. By moving it at relativistic speed or placing it in a strong gravitational field, you could, in theory, create a time difference between the two ends. Enter one mouth, and you come out the other in the past. If you could travel at 99.999% the speed of light for what feels like a few years, decades or even centuries could pass on Earth. In fact, Einstein showed that time is not separate from space. Together, they form a four-dimensional structure called space-time. And in this space-time, time doesn't just tick forward at a steady rate for everyone. Instead, time is relative. Einstein's equations, particularly in his general theory of relativity, don't explicitly forbid backward time travel. In fact, they allow for hypothetical solutions known as closed time-like curves. These are paths in space-time that loop back on themselves. In theory, if you could travel along one of these curves, you could end up at a point in the past. The faster you move, the slower time passes for you compared to someone who's standing still. This phenomenon is called time dilation, and it's not a theory yet, has been proven through experiments with atomic clocks on fast-moving jets and satellites. Today, we are diving deep into one of the most fascinating, mind-bending questions humanity has ever asked. Is time travel really possible? To answer that, we must begin with what time actually is. Most of us think of time as a river. In other words, time travel into the future is already a scientific reality. But here comes the real question. Can we travel backward in time? This is where things get strange and controversial. One of the most discussed ideas for backward time travel involves wormhole shortcuts through space-time. Sounds amazing, right? Then there's the problem of paradoxes. This paradox has puzzled scientists and philosophers for decades. Some physicists propose a solution known as the Navikov self-consistency principle. Others propose an even more radical idea, that changing the past creates a branching universe, a new timeline. This is the basis for the multiverse theory. Quantum physics adds even more fuel to this fire. Some scientists, like Kip Thorne, have actually calculated what it would take to build a time machine using wormholes. And yet, the more we study the universe, the more it challenges our assumptions. So is time travel possible according to physics? Thanks for watching.